Hey, we're going to finish our section on functions by talking about one of my favorite topics in this field, which is what are called inverse functions. These are the functions that take a particular choice of function and tries to undo it. So we've seen examples of this before. We've seen things like x squared and square root of x, exponential functions and logarithms. Inverse functions just generalize this. So we say that for a given function f of x, the inverse function of f is the function that undoes f of x. And we denote it f inverse of x. So more precisely, we say that the inverse function has the property that if I compose f inverse, or I compose f and f inverse, and apply it to any point, I get the value x back, i.e. f inverse composed with f does nothing to the input. So the pictures maybe is something like this. I start with a point x, and I send it to f of x under my function f. And then if I apply f inverse, I get back to where I started. So it's just a way of undoing your function. Let's look at a few examples and we'll see how to compute these. So for example, if f of x equals 4x minus 3, the easiest way to compute the inverse of this is to write y equals 4x minus 3 and switch x and y. So this goes to x equals 4y minus 3, and we now solve for y. So I write x plus 3 equals 4y, so y equals 1/4 times x plus 3. This is f inverse of x. So we can check that this works. F composed with f inverse is 4 times 1/4 times x plus 3 minus 3. And I'd like this to be equal just to x. So this is equal to x plus 3 minus 3 because these cancel. So I just get x. So f inverse is correct. The key here was the following. It was to switch the roles of x and y and then solve for y. So this will work a lot of the time, but not always. Most of the examples on the CLEP, this will be completely sufficient to solve for the inverse function. So it's a good trick to know. Let's look at another example of this. So we'll look at f of x equals 1 over x minus 1. And our goal is to solve for the inverse function. So to find f inverse, write as y equals 1 over x minus 1, then switch x and y and solve for y. So we get x is equal to 1 over y minus 1, and now I have to solve for y here. So x times y minus 1 equals 1. So xy minus x equals 1. X times y equals x plus 1. So y equals x plus 1 over x. And again, we'll check that this works. F composed with F inverse of x is equal, so this is f inverse 1 over x plus 1 over x minus 1. So 1 over x plus 1, I'll get a common denominator here. And this gives me 1 over 1 over x, which gives me just x. So the inverse function was computed correctly. So again, this trick of switching the roles of x and y and then solving for y to get the inverse function is essential for the CLEP exam.